Alright, so now let's get going on the best project of the year, the zombie project.
Alright guys, so here is the zombie project. So, just a little explanation and then an example on how to do the project. So you live in, and first you have to decide on a city, okay? Now you can't just pick any city, okay? I do have a list of pre-approved cities, and in class you'll sign up for those. But if there's a city that's not on this list that you would like, come talk to me, and we can take a look at it, okay? So you pick a city, okay? In this case, we'll just, for our example, use Lisbon here. Okay, so the date is 2/14/19. That's coming up pretty soon from when I made this video. Maybe you're watching it after. The news just reported its first infection of the mind-destroying contagious disease dubbed Z disease, or simply zombie. You're working in a government department to try and understand how long until the whole town is infected. Plus, you need to help get the population to leave. Before your assistants were turned into zombies, they were able to give you some data on how fast the zombies are spreading. Okay, so that's in the table below. Now, again, you don't just pick your numbers. I've got some tables here of the infection rates, and you'll choose these in class as well, so nobody will have the same one. Okay, so if you don't have that information, and I'll post that up, but if you don't have that information, you need to come talk to me to get it. Okay, so whichever one you have, you'll write that in or whatnot. Okay, you will also get a memo from the other group in charge of evacuating the civilian population. Okay, so the evacuation is going well here in your city with a starting population of, okay, you need to find the most current population you can of your city. But we are only able to get out a certain amount of people out of the city every day. This is another number you need to come talk to me about, so that we can make sure it's not too big or too little. We need to be faster but are losing military personnel due to the growing number of zombies. Please send more help as soon as possible. Okay? So, you need to get a handle on when the population will be evacuated and how much time you have according to the zombie infection growth. Okay? So, take the city you were assigned and the data showing the rate of infection and find out how long it would take you to infect the whole city, accounting for the population changing due to evacuations. Okay? Now, we are going to present this in class. So what you need, okay, here's the things you need for your presentation. City, population, the table for zombie growth, okay. You need an explicit equation, the table, and the graph of both of those situations. So the evacuation and the zombie growth. How many days it would take the whole city to be infected. We're also going to kind of go back to those key features that we learned in a previous unit and kind of connect them to our story and how they relate to the context of our story. Okay, where they meet and what that means. Okay, now you can deliver it in a few different ways. You can make a poster, just a simple portfolio, or some sort of computer program. Okay, there's also a written portion, and this is more, I should probably call it more an artistic portion. Okay, because you're either going to write a story about what is happening here, or I do allow it to have some other things too. Okay, you could do a story, or maybe like a graphic novel, comic, a really cool picture, some other thing, and you'll need to talk to me about that. But here's the rubric of how things are graded and the total points it is. Okay, so let's take a look at that example now. Let me just do these examples of what we need to do. Alright, so I'm going to hold off on this graph and where they intersect for a bit. Okay, and let's go to my table. So my table, it started out at 0, 5, then 120. So I want something like this. And this is days. This is zombies. And then it was 2 and 80, and 3 and 320. Okay? Now, do I need to finish this table and use up the whole space? I could if I wanted to, but I don't have to. Okay? Oh, that might not be right.
That's much better. Okay, so that's up to 5 days, and you can see my zombies are growing pretty quickly. So now for my equation. Okay, so we have to decide, is this a linear or exponential? Okay, so 5 to 20, we could add 15, but if I add 15, will that get me to 80? Nope, so it's most likely not linear. So let's do exponential, so timesing. So 5 times 4 would get me to 20. Times 4 is that 80? Yes, it is. Times 4, yes. So remember, for our equations, we need to know our growth, which mine is timesing by 4, and where we start. Okay, which for me was at 5 zombies, right? We look at the 0 days, we go to the 5 zombies, that's where we're going to start. And then I go, f of x equals my starting, which was 5. What do I do to 5? I times it by 4. How many times? Repeatedly. So I get f of x equals 5 times 4 to the x. That's my equation. Okay? That's my equation. So, now there's some information that I can use from that. Okay? So, let's look at where we want to go first here. Alright. Thinking about these features of functions, we usually want to graph first, but I guess what I need to decide, is this graph going to be discrete or continuous? Remember, continuous is if it's a line. Discrete would be more like dots, right? That you don't have the in-between. So let's think about our context. Okay? Am I going to have in-between pieces here? Okay? Are we going to have a half of a zombie? Okay? We could have, half of a day, and maybe we could have like 16 zombies, which would be in between there. But I can't have half a zombie. So I would most likely call this discrete. Okay? And what would be that contextual idea here is because, it's number of zombies, and they have to be whole numbers, integers. So that contextual represents that I won't have like half a zombie, though I suppose you could argue continuous as well, that someone's in the process of changing into a zombie and not fully a zombie. So honestly, it kind of depends on which one you'd like to go with, as to what you would end up with. Now we can look at the second one, increasing or decreasing. Well, the number of zombies is going up, so it's definitely increasing. Okay, what does that mean? According to our story, okay, the zombie population is rising. My goodness, I need to write better, don't I? Can't spell either. Alright. Okay. So now, there's a few ways that I could go to graph this. Okay, because a graph will help me. I could try to do it by hand. I'm going to recommend not doing that. Okay, because we have that awesome tool, that online graphing tool called Desmos.com. Okay, so that's where I would go, and then using my equation, I would just type that in to Desmos, exactly how I see it, and then I would graph that. Okay. Now, I'm going to hold off on showing you my graph until I graph the other stuff as well. The reason I'm doing that is because the graph will help me with some of this stuff. I suppose we could do the y-intercept, because from the table I should be able to see that my y-intercept is 0, 5. And what does that mean? That means at the start, at 0 days, there are 5 zombies. So at the start of the outbreak, the city had 5 zombies. Okay? Alright. Now, this rate of change, that, remember, for exponential you need an interval, okay, for rate of change. So we could think of it as our growth. Okay, how is this growing? Well, we're timesing by 4, okay, which means we're quadrupling, timesing by 4, so we're quadrupling zombies every day. The number of them. Okay, so on linear that rate of change would be slope, and I still want to show you how we'd think of this as rate of change as well, to kind of see how that works as well. Alright, so we've got quite a bit of stuff there to go with, but now let's take a look at our population evacuation. Alright, so this one, let's think. Okay, before it starts, before we start evacuating people, okay, how many people do I have? Well, my population, what was it, 35,854. Okay, so here's my number of people, my population in the city. This would be days again. Okay, so at 0 days, I had this population. Now, what's happening? Okay, it says we're getting 1,200 people out of the city every day. So what is happening to my population? Well, we're losing 1,200 people every day. Okay, so I want to fill it out probably about to the same place. So I'm going to subtract those. So I go 35,854 minus 1,200. That gives me 34,654 after day 1. And then minus 1,200 again to get 33,454. And then 32,254. Then 31,54. And finally 29,854. Now, obviously this will keep going, so that's why we make our explicit equation. So now this one's linear, because we're subtracting by the same number each time. So I know it's linear, so it's going to be, we'll call this one g of x. G of x equals, what did we start with? My population, 35,854. We're subtracting 1,200 each day, so that one gets times by x. Okay, so once again, I look at this one, is it discrete or continuous? Okay, well, can you evacuate half a person? No, but could half a person be evacuating? Yeah, so once again, it kind of depends on how you want to phrase it. If you're going to choose discrete, you need to say something like, I can only evacuate full people. If you're going to go with continuous, you would say, people are continually evacuating. They're just not completely evacuated yet. So that's kind of the contextual meaning you'd have to put into either one of those. Now, looking at this, my numbers are going down, so we're decreasing. So what does that mean? Why is it decreasing? The population is going down because people are leaving. They're evacuating. Okay. Now, for linear, the rate of change is pretty easy. It's that slope, right? And we could graph it as well, and we could find that rate of change through that, which we'll be able to see when we look at if we do it through the interval too. So we'll do it both ways, just like we did exponential. So if we do the slope, it's 1,200 over 1 and a negative 1,200, right? So what that means is we lose 1,200 people every day, right? That's the context there. Alright, and that rate of change will mean the same thing. We can see how we could do that one through an interval as well. Alright, so the other one we could do is a y-intercept, okay? Because that's where we start, right? So our y-intercept is 0, 35,854. So what does that mean? That's our population at the start of people, not of zombies. Okay. So now we can, on Desmos, we can use our equation here and we can graph that. Okay. That's why I would hold off, because that's going to help me see what kind of window I need to make. Alright, so a few things about Desmos to help make it easier. When you go to Desmos, you'll click to the calculator and it'll give you here. This obviously is where you put your equations. Notice I put them in exactly how I wrote them. Okay, they gave me the colors there. So I know I can only see red, I can't see my blue. Why not? Because my y-intercept is so high. That's just a 10. So over here, you can click on this. You can click on projector mode, which makes the graphs thicker. And then you can adjust your x and your y axes to help you see the whole picture. Okay. Something else you can do, if you click up here on that settings and you click over here, you can change from discrete to continuous, and you can change the colors as well. You can also put them into tables and some other things like that. Okay. So there's multiple ways that you could end up doing this. Okay. But if you decide to go discrete, it would look something like this. Okay. If you decide to go continuous, it would look like this. I'll probably just keep mine as continuous. But we'll treat them basically the same way. Now, from this graph, and notice I changed mine to green. So green is our evacuation formula, and purple is our zombie formula. Okay, so looking back here, we need to figure out our domain and our range. Now remember, domain is all the x values that make sense in our story problem, and range is all the y values. Okay, so looking at our evacuation, can we go back to negative days? No, so we'd start here at 0. The x value of 0 would be where we start. Okay, and we go to here, to our x-intercept, which, by the way, is another 29.87. Okay. Okay, and what does that x-intercept mean? Well, the x value, remember, stands for days. So it would take us 29.878 days to have 0y, and y is our population. So what's our contextual meaning? 29.878, basically 30 days to empty the city. Okay, that's what that contextual meaning is. Now going back here, okay, so beyond that we have nobody in there. So this would be our domain for our problem. We can actually go into Desmos, and you can use brackets right after your equation, and you could go 0 is less than or equal to x is less than or equal to 30, basically. And you could type that in right there, and then it would cut it off just at those pieces. Honestly, you probably should do that. But there's our domain. So domain is just x value, so we'd go 0 to 29.878. So you write that in like this, 0 to 29.878. And what does that represent? Okay, here it represents days from start to finish of evacuation. Okay. Now the range are the y values. So we start here down here at 0, right? And we go clear up till our population of 35,854. So our range would be from 0 to 35,854. And what does that mean? That's just our population. Okay, how many people are in the city? Alright. Now, that rate of change. So, we'll get to that one in a second. Let's look now, we need to do the same stuff for our zombie. So, what's our domain? What's our range? Okay, well, our domain here would be from, okay, where we start, which was right here. So once again, that really shouldn't be part of our graph. Okay, our domain till when? Okay, well, maybe it helps to talk about what's going on right here. Okay, what does this mean, where they intersect? Okay, x, remember, was days. Y was either population of people or zombies. Okay, so let's actually go back here. So I made just a little bit nicer graph right here. So where do these functions meet, intersect? Well, they intersect right here at 6.235 to 28,371. 0.853. Okay, so what does that mean? Well, like we said, if x is days, in 6.235 days, the number of zombies and the number of people in the city will be the same, which would mean that all the people in the city have been turned into zombies. Okay, so the x is day when all the people are zombies. Okay, that's what you're kind of looking at there. Okay, so for our domain here, that's where our domain would end, because if there's no more people, you can't make any more zombies. Okay, so from 0 to 6.235, okay, and then our range would be from 5, right? Because we start at 5 up to 28,371. Point whatever that was. What was that? 0.853. Okay, and what's the meaning? You know, that's the population of zombies. The number. This is days, right? Till everybody's turned into zombies. Alright, now, x-intercept for exponential. Remember with exponentials you have that asymptote? So our asymptote is going to be here at the x-axis. So it's actually never going to have an x-intercept. Okay? Because there's no point where there's no zombies. Alright. So we've got that information for you guys there from my example. That's how I would do it. Okay, yours is obviously going to be different. I would suggest using Desmos to help you out with that stuff. Now, rate of change. So rate of change, if we're thinking about this, okay, for the linear, we'd go down here and here. So this y value minus this y value would give us a difference of 7482.147. Then this x value to this x value would give us a difference here, so it would be 6.235. So the rate of change, if we're doing it based off this information, would be 7482.147 over 6.235, which if we type that into a calculator, we get 1200.023577. So basically what we said. Okay, because we're dealing with a situation where it's not exact, that's why we get that little bit of a decimal. But that's our rate of change. So per day, once again, that's how many we're losing. Now, if we do it for our exponential, okay, the difference here is we're going up from 5 to this number. So I'd go 28,371.853 minus 5 to find that difference, that y value of 28366.853. And then once again, 6.25, so I'd go 28366.853 divided by 6.235 to get that one, which would be about 4549.6155. So basically about 4,549.50 zombies per day. We're quadrupling them, remember, so when we're down here, there's less and less, but they move so quickly. But if we were to graph that linearly, that's how many zombies essentially per day we'd be having, okay? So that one would kind of go here with this, the 4549.50 0.62. Okay, meaning the same thing. All right, so there we go, guys. There's some basics there for that. Now, one other thing I would want to add, make sure you're using your numbers. If you have questions, let me know. If you need your data, let me know. Pick a good city, fill this out, and then give me a good presentation, okay? Use Desmos for your graph. You can graph by hand, but Desmos is so much easier. Now, for your artistic part, you need to blend that math in, okay, to the story, using the information you found out based off where they intersect, okay? So be creative with this. You will need to, if you're doing something other than a story, you need to make sure you approve it through me first. But, you know, use that city. So like Beja, if I'm looking at Beja here, so I'm going to use stuff like this map. I'll look it up. Use these roads, okay? There's, in the center of town, there's this big tower surrounded by walls, you know. That would figure into my story or my picture or my comic. Okay, here's a view from up here looking down and seeing the city. Okay, I would use this information to help color my story. I would also use this information I got from my graph. The contextual meaning, all this information I would incorporate, synthesize into here so that at the end you come up with a really great story that fits in mathematically, fits in with the city I'm at, to make it really have some fun with it. So there we go, guys. There's kind of an example, an outline, a basic idea on the presentation. Make sure you have a good way to do it. You spend some time on this and make things look really great. So other than that, make sure you let me know if you have any questions or if you need any help or anything like that. And good luck with it. I'm excited to see what you guys come up with.